So we have two types of II. First, we have type 1 and also we have type 2. Okay, type 1, if one or both limits are infinite or we have infinity. And also for the type 2, if the function is undefined at certain point. Okay, so we have two types of improper integral. We have two types of II. So type 1, if we have the limit, it's either 1 or both limit are infinite or infinity. And for the type 2, if the function is undefined at certain point. Okay, so this is type 1. So type 1 is if we have limit infinity. For example, number 1, if the function is continuous in the interval here. Okay, so we have infinity at the upper limit. So what you need to do, so limit when t approaching infinity, so you change integrate from a to t fx dx, and it happened at negative infinity, similar to the first case. So you need to put limit when t approaching negative infinity. And then what happened if we have negative infinity and infinity? So you need to change to this form. So c can be any real number. For case number 3, if you want to prove it's the integral is converge or diverge, you just need to show one. Okay, it's either this integral or this one. And if let's say you show this one and it's already converge, so you don't have to show this one. But if you're doing this one and then the answer is diverge, so you need to show also for this one. If let's say this one is converge, so the integral is converge. But if the integral is diverge, so the answer will be diverge. Okay, alright. Okay, for the note, the improper integral in 1 and 2 is said to be converge if the limit exists, or we get the final answer, and diverge if the limit does not exist. And the improper integral number 3 is said to be converge if both terms converge, and diverge if either term diverge. Okay, so okay, let's okay, let's try this one. Example 4.4. Okay. Example 4.4, number 1. A. Integrate from 1 to infinity 1 over x dx. Okay, so we have limit infinity. So the first thing that you need to do, you need to apply limit. Okay, you need to apply limit. So limit when t approaching infinity, t 1 over x dx. Okay, please remember you have to put limit. Okay, you need to apply limit. If I'm not mistaken, we have marked if you apply limit. So please apply limit. Okay, and then limit when t approaching infinity, so integrate 1 over x, we get ln x 1 equal to limit when t approaching infinity ln t minus ln 1. Okay, so this one obviously equal to 0. So this is the graph of ln and our t is infinity, approaching infinity, therefore ln infinity equal to infinity. So diverge. Okay. B, for B, integrate from 0 to infinity x exponent negative x dx. Okay, so we have infinity here. So first thing what you need to do, you need to apply limit. Okay, you need to apply limit. Oh, x negative x dx. Okay, so now we have x polynomial and exponent negative x. We have exponential, so back to lipat. So polynomial, we have to differentiate. So u equal to x du equal to dx, and v equal to integrate dx. So answer is negative x. So apply the by part. By part is u v minus integrate v du. So limit when t approaching infinity. So uv negative x exponent negative x. So minus b, so minus is plus. Integrate v du is dx. T equal to limit when t approaching infinity. So negative x negative exponent x 0 to t, and then substitute the limit. So we have negative t exponent negative t minus negative t minus plus 0, so plus exponent 0. So this is the graph for exponential. So we have limit approaching negative infinity. So this is a graph for exponent, but we have negative infinity, so approaching 0. Therefore this one equal to 0. So answer is 1, converge. Okay, and then question number C. Integrate negative infinity x over 1 plus x squared dx. Okay, so for this case, the limit, both limit infinity. So what you need to do, you need to separate this one to c. C can be any number, but for this case we apply 0 over squared dx plus infinity x over 1 plus x squared dx. Okay, so you need to separate these two, and then you can choose either one. If you want to solve this one also can, if you want to solve this one also can. So you just need to solve one first. Okay, you need to show one first. If let's say when you solve for this, for the left side, and then you get the answer diverge, so you make conclusion. Wait, back to this one. So improper, the II implicit to be converge is if both term converge and diverge if either term diverge. Okay, if let's say when you solve for this one and it's already diverged, so you don't have to show for this one. So you just make conclusion, this improper integral diverge. But if you show this one, the answer converge, so you need to show for this one also, and both converge, and then you can make conclusion, this this improper integral converge. Okay. Alright. Okay. Now, if let's say I want to solve this term, I need to apply limit. We need to apply limit t approaching negative infinity, t 0 x over 1 plus x squared dx. Okay. What we need to technique of integration. So substitution. So u equal to 1 plus x squared du over dx equal to 2x. So du over 2 equal to x dx. So substitute limit when t approaching negative infinity, t to 0. So du over 2u equal to limit when t approaching negative infinity, 1 over 2 ln u. U is 1 plus x squared, t 0. So limit when t approaching negative infinity, 1 over 2 ln 1 minus 1 over 2 ln 1 plus t squared. Okay, this one ln 1 obviously equal to 0. So ln, this is the graph for ln. So now ln approaching, so t squared, so t squared infinity, positive infinity, ln infinity. So answer is infinity diverge. Okay. And then question number 2, for what values of p is the integral convergent? Okay. Number 2, number 2, 1 to infinity 1 over x power of p dx. So we need to solve this equation and we need to find what is the value of p, so that this integration, this improper integral becomes converge. Okay. So first, don't forget to apply limit. Okay, please apply limit. 1 t 1 over x power of p dx to limit when t approaching infinity. So x p minus, so negative infinity plus negative p over negative p plus 1 equal to limit when t approaching infinity. So t 1 minus p over 1 minus p minus 1 over 1 minus p. Okay. So t approaching infinity, and we need to find what is the value of p. Okay. So because of the denominator 1 minus p, so p cannot be 1. P cannot be 1. Obviously p cannot be 1. So if we want to choose the value of p, so for the first case, what happen if our P is greater than 1. For example, P equal to 2. Okay. So we try to substitute into the limit. So, T 1 minus 2 is negative 1 over negative 1 minus 1 over negative 1 equal to limit when T approaching infinity negative 1 over T plus 1. So 1 over infinity limit when T approaching infinity, so negative 1 over infinity plus 1 over infinity is equal to 0, so we get 1. So converge. Okay, now we need to check. Okay, we need to check what happen if our P is less than 1. For example, we choose 0. Limit when T approaching infinity, so T 1 minus 0 equal to 1 over 1 minus 1 over 1. So T approaching infinity, so obviously it will be equal to infinity. Therefore, if we want our integral to be converged, therefore P should be greater than 1. Okay, so this is the answer.